We want to give people access to our data. That in itself is what you call like a service, right? It provides value, a lot of value to whoever's, whether it's another company or a user, whatever. The database is exceptionally valuable, probably like the most valuable part of any tech company. So the way that we kind of select, insert in data to a database is through the model. This is what's closest to our database, and we said that we have this mapping, right, between like a table and a class, right? Select all from products. Here we have a class product, and also like a row in the table, and an instance, right? We create an instance out of a row of data, okay? And that was like our ORM, right? This idea is like our object relational mapper, right? Where by the word relation, you can just insert the word table, right? It like map an object to data in a table. Now, the way that people ask for information is by making a request and then us giving back a response. So that's the controller's job, right? The controller has all these different routes that are defined, and someone goes to /products, and then you can see we call either like the product.all if we have a class method, or we can do the find all product thing, and that will then underneath perform select star from products, right? So you want to be able to kind of to go from this level of abstraction, find all product, and then understand what's going on under the hood. But this controller is what takes action in our application, right? It gets a request, and it's the thing that actually executes a method, right? This is what triggers all the action. And then it sends back JSON, right? That's the view, right? Is what the user sees, what is sent back to the user. So someone makes a request. They say, I want to see the products. This calls product.all. That's like a model method or like an ORM type method. Then that performs the select all from products. We get the products right here. We turn the product into JSON somehow. Maybe we have a method called like toJSON. And then we send this back to the client that's requesting it, whether it's a browser, whether it's a curl request, whether it's the request.get method, right? That's what we do. This so far, right, assumes that we have data in our database, and then of course the next step is now this adapter pattern, which is how we pull in data. But before we get to that, right, this model view controller type pattern, questions about this? Because this is a very typical pattern, right? You can Google it, you can like read about it on Wikipedia. If you do Ruby on Rails, you'll see this pattern. If you do Django, you'll see this pattern. Probably other applications. If you do Node, you'll see this pattern, right? So that's why, like, if you like hear like, oh, this programmer can like code in like 8 different languages. That's why they can code in 8 different languages, because the pattern, the concepts are the same. Yeah, Bryn?
So this explains a lot, where each model kind of has a different route in the controller, almost like, so the controller, it's almost like in the Flask, create app function, you'd have all of these, it's kind of that same deal where you have all these routes in the controller.
Exactly.
So I guess, are there any exceptions to this pattern?
Well, you don't need to have a control. So each method here, like def products, I call that like a controller action. Okay, so maybe the controller is that whole file that has the create app in it, but each route and the corresponding method is a controller action. So to answer your question, you don't need a controller action or a route for every single table. For example, right, like we don't have one for like our join tables oftentimes, right? Like if we have, like if you think about like a movie has many directors, there's that table called movie directors. We don't have a route called like /movie directors. Just the same way in the Google Books API, like a book has many authors. You don't have like a book's authors route. You just have like a books route probably and an authors route. Yeah, go ahead.
So is it, I guess the pattern that I see is like for every query input, you want to have that route in the controller. And then that would correspond to a model. Actually, because I was working with the Spotify data, and there's a lot of different terms that you could query. And then if you search for, you can search by artist and then refine it by year. So I guess that's what I had in mind.
Yeah, so I mean, if you think back to like our lesson on APIs, really like the terminology is resource, okay? Meaning like, right, that and this comes from this REST pattern, right? That's which is how APIs and really like the web is designed, right? When we talk about like ESPN.com and then going to those different places, those different URLs, whether it's like NHL/teams or NHL/players, right? These are different resources. And so for here, maybe we'd have like products, right? Maybe there would be like some businesses. If let's say we're designing Amazon, right? There's like these sellers, there's customers. And what's nice about resources is they typically, like what you can do with the resource is our typical, and maybe I'll turn this into like a lesson, I think, is our typical like CRUD applications, right? You can add a new product, you can view the existing product, and then you can view all the products. That's kind of like the index, read all. We call this like the show. This is the index. You can update a product, right? Like, oh, now it comes in this color. And then you can destroy it, right? Delete it. Right? So you can think of each resource like you generally can take these various actions with them. For us, we've only really cared about these two because we're building APIs, like we're not building like a web interface, but you can think about like, okay, when a seller signs up, that's the create action, right? When they like say I'm now a seller here and they submit a form in the website, that's like a create action. So any website that you like think about, that you think through, like Twitter, Facebook, right? Like any Instagram, it doesn't matter. Any website that you work with, Yelp, get used to like a good practice is like, what are the resources there? It's really kind of like it's a different frame. When I first learned about it, I just found it like very interesting that like, oh, like this really simplifies all the actions I make on the web. Oh, a tweet is just a resource, right? Like Twitter just allowed you to delete it, right? But like we kind of expect these different abilities, these actions that come with a resource. Cool. And then from the resource, then it's like, okay, these are the resources. Then each one of these generally does have a table associated with it. But but there could be additional tables like the product sellers table. I wouldn't call product sellers a resource, but maybe to some degree, like in the sense that maybe you like someone might not want to hit the product sellers route, but still like these same actions apply in the sense that what you're creating. When you create a product seller, what you're doing is you're creating the link. This seller now sells this product in addition to the previous ones, right? So you still sometimes it still is useful to just be like go through the CRUD operations and see what you can do with it. Cool. There's a great book that called I have it on my shelf called Beginning Database Design. Which is good. There's also, I know the end is called For Mere Mortals. I forget if it's like REST. I'll have to Google it. It's like REST for Mere Mortals or something like that. There's one called Database Design for Mere Mortals, which is also kind of interesting. That's what it's called. All right, so it is useful, like when you can see what's nice is like, the web, like these are the routes. So when you go to ESPN.com, right, this is the resource. This is sometimes called a nested resource, and this is the show, right? Like we're viewing this individual story from the MLB. They're doing a find by ID right here, right? Just like we do. Cool. Other questions about this MVC pattern? Okay. So this is like assuming that we have data in the database. Then the next, oh yeah, Jeff, go ahead.
So MVC is like REST to the REST actions, like GET. Are all of those a GET, or are some of them GETs or other things? Or?
Yeah. So good question, right? When you have what do we have? 5 actions here, right? They basically divide into 2 different, I don't know, categories. I forget exactly, but either they're going to be GET or POST. There's also something called like patch/put, but that to me, what is like a form of POST. Okay, so what's the difference between GET and POST? GET is when we're not changing anything in the database, or maybe a better way to put it is we are not changing our data as a result of the action. And then POST is we are changing our data as a result of the action. So then it's like, okay, well, when are we changing our data? Well, actually a few of these, right? Create, we add a new record to the database. Update, we alter that record. Delete, we destroy that record, right? These are all POST requests, okay? These 2 are GET requests. And those 2, as data engineers, that's generally what you're designing for, because you're allowing access, to the data. You're building like this API, and then maybe you don't even need a front end. You can imagine if someone, when you send a tweet or you like post a Facebook status, right? Those are creating, right? If you edit the image, right, you're updating. If you delete it, you're deleting, right? So for a web application, like these are essential. For like kind of an API that we're building, like think of like the Google Books API, like we don't really have an interface for like submitting it. I don't know if they do, they probably do at this point, but maybe as an initial step, they performed more of this. I'm just gonna like copy the CSV, and just insert all these records into the database directly. Like there might not have been like a route, like this kind of thing, to like actually submit it. They could just do what we did, right? Copy the CSV file into the database. So yeah, these actions divide into these overall groups of, are you changing the data? Are you not changing the data? The reason why we care about that is we'll think about like read access versus like, change access, right? Like you give people like when you like befriend someone on Facebook or whatever, or make your profile public, well, they have read access, right, to a lot of your information. They don't have post access, right? They can't change anything, right? This is considered more dangerous, right? Because you're actually allowing someone to alter data in your database. The reading is, as we may want to protect that as well, but is not as drastic as posting, right? We probably would require a higher level of authentication for any of the post actions as opposed to any of the GET requests. These are kinds of requests. That's what I should have said. These are either GET requests or POST requests. And we've seen that, just by virtue of the API, the request library, right? There's requests.get, right? The URL, that's a GET request. And then there's probably also requests.post, right? To update data if you need to. We haven't really dealt with this because again, like as data engineers, we don't use this as much. This is more like web development, but it can be used. Yes, Serge?
Can you please talk about the view in the MVC pattern?
Yes. Okay. The view is the response. Okay? It's what are you sending back? Now, when we're building an API, that response is really one line. JSONify products.json. But if you think of like a web application, that view can be exceptionally complex. That is like what a front-end developer does. They're building the HTML, the JavaScript, CSS, images, everything that you see when you go, to inspect, when you do that like inspection or like view page source, all this stuff is sent back to the user. What I don't have is I don't know like the tables, right? Like I don't have the actual raw data necessarily. I get this back, right? That's the view, what is sent back to the user. And like I said, in a web application, this involves the HTML, JavaScript, CSS, right? In an API that we're building, it's a lot simpler. It's the JSON, right, that we're sending back. Okay? But this could, if it's not just JSON, but rather HTML, CSS, and JavaScript, the point is that can involve a lot of data, right? If you want to see an example of this, I'll select this out. You can see this in the Foursquare full stack, the lab you're about to do. Don't look at this till later. But here I have a front end part, like a totally separate folder. Like this could be totally separate repository. And this front end, displays like you might notice the scatter charts, things like this is all the view, right? If someone wants to see a dashboard of like some of this information, all this is written in this separate. This is pretty simple, but there could be hundreds of files just related to the view level, right? Cool. All right, so that's this MVC, and then it seems like maybe we'd benefit from a review of REST or like some sort of quiz or something like that. We can do that. All right, so that's this MVC component. Just in terms of how do you understand an application, you can look at the tables, but oftentimes there can be more tables than there are routes. So even simpler than that is to look at the routes, because that's telling you what's the resources. So if you want to get an overview of an application, say you're given a new repository, this is the file I'd look at, the controller. And that's where I'd start. And then next I'd probably look at the models or the schema, right? The create tables file to tell me the various tables in the database, right? Because you're just getting a sense of the overall structure of these tables, right? And the most important ones are probably associated with routes. Okay, so then we have to pull in the data, and the general idea is, we have one class that's in charge just of hitting an API. Well, let me even start backwards. The reason why we have this pattern, is let's say we're pulling in. Let's say we have our Yelp thing, right? Or we have our venues. Okay, so we have this venues table, and there's all this stuff we want to do with the API, which is we want to allow people to find by the price of the venue, and we want to allow people to find by the category and things like that. Now, we may start off building that application by first oh, it's great, we can just pull in all this Yelp data, right, and get our data loaded in there. And then it turns out Yelp goes out of business, or they just shut down all access to their data, and so we can no longer use Yelp. Or let's say we use Yelp, but it's just not enough, so now we want to use in Foursquare, right? Once we load the data, if we kind of transform this data such that we load it into this venues table, this same venues table, and have this model that's associated with it, we can stop caring about where our data came from, right? Because it's all, to us, it's all just a row in our venues table, and it has the same methods, right, as anything defined in our venues class. So it simplifies things. This data is going to start off as messy. The Yelp data is going to be different than the Foursquare data, which is going to be different than whatever, right? So if we can transform this data, right, they're all starting off differently, but if we can kind of shave them and manipulate them so they all fit into this, box, right? That's very useful, because it means we can treat them as if they're the same, and instead of writing 5 different methods for 5 different data sources, once we put them in this format, we're good. Okay, so that's the whole purpose here, is we're going to be getting data from different APIs, and this data is going to come back to us differently, But once we do this step of coercing this data and load it into our database, then we don't have to think about this anymore, right? That's the idea. Over here, once the data is in our database, we just apply our model view controller, right? We don't worry about where, to some extent we do, but in general, we're not really worrying about where our data came from. We're just treating it the same. Oh, this is a 5-star rating. It has the rating. It has, the price. It has whatever, okay? So that's the whole point of this adapter pattern, is this data is going to come out messy. It's going to have too much information that we don't really need. So instead of handling each data separately every time I want to use it and considering where did it come from and oh crap, it's over, this information is over here. Now let's right from the get-go transform this data so that it just looks the same, right? So that we can treat this data the same as much as we can. All right, that's this idea of ETL. So how do we do it? So we have this extract and transform. That's kind of that's really the main thing, is hit the API. Why do we care about, we separate this into a class? Because if you think about, let's say you think about ESPN, let's say they have an API. I'm going to need a client that has, that's just in charge of hitting the API, but and that might involve a good amount of work, like the API keys here. I need to know about the root URL, the different routes that are available, any of the query parameters, right? That's all particular to the API. This transform thing, right? This is called the adapter in design pattern speak. It's called transform, I guess, more in data speak. But this whole point is just like an adapter, in your wall socket, right? It's the bridge between this external thing and the resource, right? You trying to load this data into your table. Okay, so this is the bridge between this API and this. Now, one question maybe you ask is well, can I just combine these two into one? And the reason why you don't want to is because, well, okay, I'm pulling out product information here, and but maybe I also want to pull out seller information. So you can imagine having, a separate class transformer for class seller builder. Okay, so this is now going to be the bridge between still my Amazon API, but now a different table. Okay, because there's a good amount of work, as you'll see. There's a good amount of work, and what you're going to be doing, in fact, is building a separate builder for each table, even though we're only using one API. All right. So for instance, with the venues, you're going to be building there's a venue builder, but then there's a city builder to build each new city that we see, and a state builder, and a categories builder, right? Each one of them is the bridge between the data we're getting from our API and the table that we're loading it into, right? That this is what's actually doing all the cleaning, the coercing of the data, so that we can then load it into our database. All right. So the model, because we have this model, we can just create an instance. The idea is for each product, you can see what we're doing here. We define a product builder. It's not this simple. There's a def run, but the general idea is, okay, we somehow are going to call our client.run. That goes and makes a request, gets back our JSON. We get that response.json. And then getting that data, then for each dictionary, we get back our list of dictionaries. For each dictionary in the list of dictionaries, create a new object, right, from our model, and then save it. And the save does the insert into under the hood to load it into the database. So you can see, right, db.save does the insert into. All right. I'll send this to you so that you guys can hopefully talk through it yourself. That would be a great task, right? These are kind of two classic interview questions, very classic. You know that because you asked Brian about it, and he told you how often he's seen them. All right, so any questions about ETL or anything else that came up? But you can see also I'm trying to label it here. Here's the adapter pattern, and then here's the MVC pattern. But they do, right, talk to each other. All right.